Hey everyone. So we are trudging along through radical expressions here. We have covered simplifying radicals, and then we, in the last few lessons, worked on all of the mathematical operations. So we went and added radicals, we subtracted radicals, multiplied radicals, and divided radicals. Okay, now today we're going to do very similar things, but we're going to throw letters in there. We're going to throw some variables in there. Okay. So it's not going to be bad. It's going to be awesome. Don't worry. Everybody gets scared when we put letters in. Okay. So let's just start by trying to simplify some of these things together. Okay. So just let me get my ink on here for a sec. Okay. So what I need you to see here is, well, what is the square root of x squared? Well, what's the square root of 7 squared, right? That's the same as saying root x times root x. And we've talked about the fact that anytime you multiply a radical by itself, it undoes the radical. Okay, so the root of x squared is just x. Okay, just x there. All right. Just trying to advance my mouse and it's not, there we go. Okay. So what if we had the root of x cubed? Well, the root of x cubed, we already know how to deal with x squared, right? X squared times x would be x cubed. So I could break that down into x squared times x. And that would still be x cubed. So the root of x squared is x, and then I'd be left over with that root x. Okay, so we would have x times the root of x. Now, again, what did I do there? The root of x squared is that x right there. Okay, the root of x squared is that x. Okay, so the root of x4, well, x to the 4, isn't that x squared times x squared? Okay, so isn't that like x times x, because the root of x squared is x. Okay, so then x times x is x squared. Now, just in case, I want to make sure you're following what I'm saying there. So let's just go, and I said, okay, this is like the root of x squared times the root of x squared. Okay, and then I know that the root of x is x, and then the root of x is x. So altogether, it's going to give me x squared. Okay. Is that okay so far? All right. Then the root of x to the 5. Well, if I have the root of x to the 5, why can't I just say, okay, well, that's going to be x to the 4 times x. Oh, don't know what happened there. X to the 4 times x. And then they're both under roots right now, right? So if they're both under roots, the root of x to the 4 is x squared. So I end up with the root of x squared times x. Okay. So then the root of x to the 6, I'm going to start speeding this process up because I'm hoping you're starting to see some of this. I can call that the root of x squared times the root of x squared times the root of x squared, right? I'm just going to draw that for you. I said I was going to speed up, but I just want to make sure everybody's comfortable. Root of x squared, root of x squared, root of x squared, right? Because x to the 2 times x to the 2 times x to the 2 gives me that x to the 6. Well, that's going to be x times x times x, which is x cubed. Now, I want you to notice really what happens is when you have an even number, the square root of the even numbered exponent is just going to be halved. Okay, if you have an odd number, you'll take your even number out, and then you'll be left with root x to account for that odd number. Okay. So then finally, with the root x to the 7, I'm going to find that root x to the 6. I'm going to take it out, and that'll be root x to the 3, but then I've got one more x there, so that becomes x cubed root x. Okay, x cubed root x. Okay, Now, let's start doing things a little bit more complicated then. So root x plus 5 root x. Well, I can't do any simplification. Like I can't make the radicand any smaller is what I meant by that. I can, though, add those two things together, right? This is like 1 apple plus 5 apples. 1 apple plus 5 apple is 6 apples. 2 root 4x squared minus 16x to the 4. Okay, so the root of 4 is 2. The root of x to the 4 would be x squared. So this could be 2 times 2x squared. The root of 16 is 4, and the root of x to the 4 is x squared. So this becomes 2 times 2x squared minus 4x squared. I just simplified the radicands first. Now that becomes 4x squared here, 2 times 2. So I end up with 4x squared minus 4x squared, which is just 0. Okay. All right. So again, separate this into the perfect square portions and then the non-perfect square portions. So 18 is 9 times 2. X cubed is x squared times x. So what I'm going to do is I'm going to just separate this into 9x squared. That's my perfect square portion. Okay, I know the square root of this. And then I have this root 2 left over. Okay. Now, the square root of 9x squared is 3x. So I end up with 4 times 3x, and that'll be 12x. So 12x root of 2x. Okay. Okay, and then the root of x minus 5, there's nothing else I can do with that. It is already simplified. Okay. All right, so now we're going to go back and we're going to look at these 4 questions and we're going to talk about things that wouldn't work. Now, this might be a weird sounding conversation to begin with, but here's the concept I want you to think about. When we write a variable, when we write the letter x, we are saying that x can be anything I want, right? So when you see root x, just going to put my ink back on here for a sec. When you see root x, you are thinking, oh, that could be root 9. That could be root 7. That could be root 1800. But I didn't write 1800. I wrote 1000. So we'll say root 1000. That could be root -5. That could be root -11. Okay. Now, what I want you to notice here is these guys are problematic. And maybe you don't know they're problematic yet. So let's have that conversation. Can you pause me for a sec and put the root of -5 in your calculator? What I want you to notice is you're getting an error. Okay, you can't take the square root of a negative number. Now, why can't you take the square root of a negative number? Well, what you have to remember is the root of 9 is the root of 3 times the root of 3, right? It's a number multiplied by itself. You can't take a number and multiply it by itself and get a negative number, right? Because either both are going to be negative and that'll give you a positive, or both are going to be positive and that'll still give you a positive. Okay, so you can't take a number and multiply it by itself and get a negative number. That's why taking the square root of a negative number doesn't exist. Okay. So when we look at this guy here, we're going to say, oh, x can't be anything I want. We're going to have to say that x has to be greater than or equal to 0. Okay. All right, so we're going to have some similar conversations all the way through here. So the next one, what values for x wouldn't work? Now, some of you are going to say, oh, it doesn't matter, you get 0. Well, that's not entirely true. You're not going to get 0 if you plug in something that didn't work for x. Okay. Now, kind of a funny conversation because actually for this guy, everything works. And you'd be like, what? Take a look. What I'm doing is I'm taking x to the 4 in both of these. Okay. Pick any number you want and take it to the 4, and you're going to get a positive number. If I took -3 to the 4, I would get positive 81. Okay. Now, just a little side note there, in your calculator, when you're doing that, make sure you have brackets around the -3, or your calculator will give you a different answer. okay? Because an exponent only applies to what's directly in front of it. But if you put in your calculator, bracket -3, bracket, and then exponent 4, you'll get 81. So what are we saying there? We're saying it doesn't matter what I put in for x. When I go to take it to the 4, it'll be positive, and then I can square root it, okay? So for this guy, actually, everything is allowed. Now, in math, there's a way to say everything's allowed. Think back to your domain and range work. We would say x is a member of the reals, like that, okay? Okay, so for the next guy, I do have a root of x inside here. So that guy can't be negative. So we'll say x has to be greater than or equal to 0. And then this guy. Well, here's the thing I want to talk about with this guy. What you need to understand here is it's not about x being greater than or equal to 0. It's about the radicand being greater than or equal to 0. Okay, so what we would do there is we would say, okay, whatever's underneath the square root has to be greater than or equal to 0. Well, now you just have a little algebra problem to solve. Bring that 5 over, and you would say x has to be greater than or equal to 5. Okay, x has to be greater than or equal to 5. Okay, so let's just kind of take stock of what we've talked about so far. I'm just going to hide myself for 1 sec while you read those words up top. The values of x on which an expression is undefined is known as the restrictions on x. They can be found knowing that the radicand, the thing underneath the square root, has to be greater than or equal to 0. For even exponents, such as the root of x squared, the root of x to the 4, the root of x to the 6, the restriction on x is always x is a member of the reals. X can actually be anything. But then for odd exponents, x has to be greater than or equal to 0. Okay. All right. So try, so I'm just going to hide myself again, sorry. An expression in the form, the root of x minus a is defined when x minus a is greater than 0. So this is the same conversation I just had, except there's a letter there instead. So the restriction on x is greater than or equal to a. Okay, x is greater than or equal to a. So what are the restrictions on 3x minus 2, the root of 3x minus 2? Well, I'm going to take the radicand and just say it has to be greater than or equal to 0. So 3x minus 2 has to be greater than or equal to 0. Now I just got to bring that 2 over. I'm going to add 2 to both sides and divide both sides by 3. So I end up with x has to be greater than or equal to 2 over 3. Okay. Okay, so what happens when we end up with a radical that's on the bottom of a fraction? So we end up with a radical in the denominator. Well, the restrictions we've talked about haven't really changed. We just have to add a few thoughts to this. If I looked at the root of x, you would automatically tell me x has to be greater than or equal to 0. Great. But now you would look at this bottom and say, oh, okay, but x can't be 0. Okay, because you can't divide by 0. So we don't actually say both of those statements because it's kind of redundant. Look, right here, I said equal to 0. So I actually am just going to take that off and leave it as x has to be greater than 0. Okay, that's both of those statements or both of those restrictions combined into one. So whenever possible, we try and state the restrictions as simply as we can. Okay, all right. Always state your restrictions before simplifying the expression. And that's important because sometimes things look like they simplify out, but that doesn't mean the original restrictions don't go away. Or it doesn't mean the original restrictions do go away. They don't. Okay, state any restrictions, then simplify the expression. So we're looking at, just gonna get my ink on here for a sec. We've got 6x squared. Well, I know that x squared could just be x. So I could write that as 5x root 6. Okay. Then I can multiply that by the negative 2x root x. Okay. And then that's going to give me, well, 5x times negative 2x would be negative 10x squared. I stated my restrictions. X has to be greater than or equal to 0 because of this guy here, right? There would have been no restrictions here because it was squared, but this guy wasn't, so I do have to state that. Then I took out my x, and now I'm just doing that multiplication to get negative 10x squared root 6x, right? Remember, multiply the outsides, multiply the insides. 5 times negative 2 is negative 10. X times x is x squared. That's where that's coming from. And then 6 times x underneath is 6x. Okay. Here, again, we'll start with restrictions. X has to be greater than or equal to 0 because of that guy there. This is the distribution property. So I'm going to go that times that and that times that. Okay. And that's going to give me negative 6 root 2x. And then positive 9x root x. Okay, so negative 6 root 2x and positive 9x root x. Okay. Again, just for clarification, how did I do that? I went negative 3 times 2 gives me that negative 6 right here. And then x times 2x gives me 2x. Then negative 3 times negative 3x gives me the positive 9x times, it's like root x times root 1 if you want to think of that, right? There is no radicand there, but root x times root 1 would still give me root x, okay? Awesome. Okay, so let's try this one. Now this guy is the, it's a binomial times a binomial. So you got to be careful. You got to multiply first, outside, inside, last. So if I multiply the first together, these guys here, that's going to give me 10 root x. Well, let's talk restrictions first. X has to be greater than or equal to 0. Okay, so then 10 root x. Then if I multiply these guys together, I'll have negative 6x because the root of x times the root of x is x. Multiply these guys together, I'll have 15. And multiply these guys together, I'll have negative 9 root x. Okay. Now, is there anything I can combine? Yes. 10 root x minus 9 root x will give me just 1 root x. Now, I don't have to say 1 root x. I can just say root x. So root x minus 6x plus 15. Okay. All right. Now, sometimes we're going to look at this and say, oh, we got to go right to rationalizing the denominator. Not necessarily, right? You want to try and do the division statements first. Can I go 15 divided by negative 3? Well, I can. That's negative 5. Can I go root of x cubed divided by root of x squared? Well, yeah. When dividing powers of the same base, I subtract the exponents. So that just becomes root of x. Now, that's it. It's going to equal negative 5 root x. But we haven't talked about restrictions yet. We got to think about the fact that x has to be greater than or equal to 0 here, but then x can't be 0 here. So our restrictions are going to be x has to be greater than 0. Okay, x has to be greater than 0. All right. Okay, now we'll take a look at this guy. I could think through the same thing because the 6 is divided by negative 2 and the negative 2 is divided by negative 2. The problem is the root 5 can't be divided by root x. So it's not actually going to get rid of the fraction for me. So let's actually simplify this guy first. Okay, I'm going to look at 24 as 4 times 6. And then x cubed as x squared times x. Remember, we always want to put kind of our perfect squares together. So I'm going to call this 6 root 5 minus 2 root 4x squared. And then I'd be left with 6x over there, right? That would still get me to the 24x cubed here. And divide that by, ooh, that was a really good division symbol, minus 2 or negative 2 root x. Now, let's talk restrictions. X has to be greater than 0 again. Okay, and then I'm going to start just working on that stuff there. So I've got x is greater than 0, and then I've got what I wrote up there. So I'll take that off. Now, 2 times 2x is 4x. Just take a look at what I did here, though. I didn't actually, I can take these 2's, divide them out, and then I can take this 6 and divide by that -2. So 6 divided by -2 is -3. And then if I divide those 2's out, I just be left with 1 2, and that's where that 2 comes from. So instead of doing the 2 times 2 is 4 and then simplifying, I just get rid of the 2. Okay. All right. So now I'm going to have to rationalize the denominator. So I'm going to have to multiply this by root x over root x. Now, just remember that gets distributed, right? This is root x times this guy and root x times this guy. Okay, so that's going to give me -3 root 5x. And then here I'll have minus 2x root 6x squared, and 6x squared can now be x on the outside. Okay. So then we'll just keep working on cleaning this up. X squared, the root of x squared would be x. So then I'll have an x on the outside. So this will become -2x squared. Okay, and then that's all I can do there. Okay, everything is as simple as I can make it. Okay. All right, let's summarize a few things here. The values of x for which the expression is undefined is known as the restrictions on x. Restrictions occur on x for 2 reasons. Number 1, you can't take the square root of a negative number. Number 2, you can't divide by 0. Okay. Odd roots, such as the root of x cubed, would have a restriction that x is greater than or equal to 0. Well, even roots don't end up with a restriction, but we say x is a member of the reals. That's our way of saying, no, x can be anything we want. Okay. All right, friends. So if you are with me in school, this is the pages for homework that you need to do. Take your time with them. Don't forget about the restrictions, okay? Lots of kids get right into the question and then they miss writing their restrictions, and then like that's part of your mark. So always start by thinking about those restrictions, okay? Give yourself lots of processing time for this and make sure you're asking me lots of questions, okay? Next lesson, we're gonna start solving equations that involve radicals. It'll be radical. All right, we'll talk to you soon. Take care.